Namaste class, welcome. Let us discuss question number 3. The question is ABCD is a rectangle and PQRS are the midpoints of the side AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. So it is given that ABCD. So I will first draw a rectangle. Okay. A, B, CD. And I will take the midpoints PQRS on side AB. I will take P on side BC. I will take Q. Here I will take R and here I will take S, PQRS. We have to show that this quadrilateral PQRS is a rhombus. So PQ, I can join this PQ, QR, RS and this. This PQRS, we have to prove that it is a rhombus. Now it looks like rhombus, huh? Yes. So if you observe, one thing is that what we can do, we can use the Pythagoras theorem. As this AB and this DC are equal in length, if I take P and R as their midpoints, then this part AP and PB, they means suppose AB is 2x. So I get this as x, and here this side x, this side x. Similarly, if I take this AD as y, 2y, then this BC will also become 2y and point S and Q are the midpoints. So this part will become y, this part will become y, this is y and this is y. So if you take Pythagoras theorem, you will get the length of PQ equal to length of QR equal to length of RS and length of SP. And hence, as all the four lengths are equal, we will say that this PQRS is a rhombus. But we will try to use the midpoint theorem what we have learned. So therefore this method I am not trying here. You can do this by this method also if it is in your exams. So if I want to implement midpoint theorem, so for that I need a triangle in which I have a side which is joining the midpoints of two sides. So for that, let us draw this diagonal AC, and obviously we will draw this diagonal BD. Okay, now here given we will write ABCD is a rectangle. Second, we will say that this PQRS are midpoints of side AB, BC, CD and DA. So PQRS are the midpoints of side AB, BC, CD and DA. Now we have to prove that this quadrilateral PQRS is a rhombus. Now proof. Okay, so here I have drawn diagonal AC and diagonal BD. One thing is that as ABCD is a rectangle, this diagonal AD and BD, they are going to be congruent, right? So here I will say that AC is equal to BD. This I will consider as equation 1, and reason is diagonal of rectangle. Diagonals of rectangle. AC is equals to BD. They are the diagonals of rectangle. Now I will take in triangle ABC. In triangle ABC, P and Q are midpoints of side. P and Q are the midpoints of side AB and BC. Therefore, by midpoint theorem, this PQ is half of AC. PQ is half of AC. This I will consider equation 1. Similarly, in triangle I will take ADC. In triangle ADC. Okay, now here we have taken AC is equals to BD. Let us take this as equal to we can take this as 2x. Okay, now this is our equation 1. So PQ is half of AC. I will say that is equals to half of 2x is equals to x. Now this we will take equation 1. Similarly, in triangle ADC, SR will be equal to half of AC is equals to half of 2x is equals to x. This is equation 2. In triangle BCD, Q and R are midpoints of side BC and DC. Midpoints of side BC and DC. So Q and R the midpoints of side BC and DC. Therefore, what we can say? Therefore, we can say that QR is half of BD. Now the value of BD is also 2x. So this is x. This is our equation number 3. And also in the same way, PS is equals to half of BD is equals to half of 2x, that is equals to x. So from 1, 2, 3 and 4, we have PQ is equals to QR is equals to RS is equals to SP, that is equals to x. Therefore, this quadrilateral PQRS is a rhombus. Okay, if all the 4 sides of quadrilateral are equal in length, then it is a rhombus. Fourth question, ABCD is a trapezium. ABCD, we can see that this ABCD is a trapezium in which AB parallel to DC, BD is the diagonal, E is the midpoint of AD, a line is drawn through E parallel to AB intersecting BC at point F. We have to show that F is the midpoint of BC. Okay. So ABCD is a trapezium. These two sides are parallel. Then we have drawn a diagonal BD, which um, we have taken E as a midpoint of AD. Okay, a line is drawn parallel through point E, which intersect BC at point F. We have to show that this F is the midpoint of BC. Okay, now here, okay, so what we will do, if you we have to name this intersection point of this side BD. Let us name this point as point EF is there. Let us name this point as point G. Okay. Now in triangle ABE. So first let us write given. You have given that quadrilateral ABCD is rhombus. Then you have given that E is midpoint of AD. Then you have given that this AB is parallel to DC. Then you have given that EF is parallel to EF is parallel to AB. Given you have to prove that F is midpoint of BC. You have done a small construction. Actually, we will not write this as a construction because we have taken this intersection point of this EF and BD as G. So in proof, it is already seen on the diagram. Okay, proof. Now, by converse of midpoint theorem, we will be able to prove that this G is the midpoint of this side BD. Okay, so G is the midpoint by converse of midpoint theorem. Now, as AB is parallel to DC and EF is parallel to AB, so EF will also be parallel to DC. As EF is parallel to DC, this GF is parallel to DC. So again, in triangle BCD, G is the midpoint of BD and GF is parallel to DC. So therefore, by converse of midpoint theorem, F will be the midpoint of side BC. So this is what you have to do. Okay. So let us begin. In proof, I will say AB is parallel to CD. Also, AB is parallel to EF. Therefore, AB is parallel to CD is parallel to EF. So all these three sides are parallel to one another. Let us consider this as equation 1. Now I will take triangle. In triangle AB, in triangle ABD. Okay, this point is D. In triangle ABD, E is midpoint of AD and EG is parallel to AB. Therefore, by converse of midpoint theorem, EG is parallel to, by converse of midpoint theorem, I will say that G is the midpoint of side BD. So for BD, G is the midpoint. Okay. Let us take this as second equation. Now we will take triangle BCD. Now in triangle BCD, G is midpoint. G is midpoint of BD, is the midpoint of BD, and G is the midpoint of BD, and GF is parallel to DC, and GF parallel to, so this is, you can say, from 2, and GF parallel to DC. This we will say that from 1, and 1 we have proved. So therefore, by converse of midpoint theorem, I will say, therefore by converse of midpoint theorem, you will say that this F is midpoint of BC. F is midpoint of BC. Hence proved. Hence proved. Okay, done. Fine. Let us see this fifth question. In a parallelogram ABCD, E and F, parallelogram ABCD is there. E and F are the midpoints of side AB. E is the midpoint of AB, and F is the midpoint of CD respectively. We have to show that line segment AF trisect the diagonal BD. So AF trisect the diagonal BD means AF divides, so that the line segment AF and EC, okay, those two line segments are there, AF and EC, they trisect BD. That means DP equal to PQ is equals to QB. That we have to prove. Okay. So let us first consider what is given. Rectangle ABCD is a parallelogram. So ABCD is a parallelogram. Next, E and F are the midpoints. E and F are midpoints of AB and DC. This is given. We have to prove. We have to prove that this AF and CE trisect. AF and CE trisect BD. That is DP is equals to PQ. That is BQ is equals to QP is equals to PD. Okay, this I will consider. Okay, this we have to prove. Let us start with proof. Here, this ABCD, as ABCD is a parallelogram, each side is equal. So we can consider that this side AB is equals to 2x. So this side will be 2x, this side will be 2x, 2x. Now as E and F are the midpoints of AB and this CD, this part will become x, this part will become x. Now if I take quadrilateral AECF, then in AECF, AE is parallel to CF and AE is equals to CF. Both are equal to X. So therefore, this AECF will become a parallelogram, and hence you can say that this AF and this CE, they are parallel to each other. Once we prove that they are parallel, I will take triangle DQC. In triangle DQC, F is the midpoint and FP is parallel to DQ. Therefore, I will say that the P is midpoint of DQ. So this DP and this PD, they are going to be equal. Then I take triangle BPA. In triangle BPA, we have E is the midpoint of AB, and this EQ is parallel to this AF. Therefore, again by converse of midpoint theorem, we will say that this EQ is this Q is midpoint of this PB. So as this PQ is Y, this also will be equal to Y. So DP equal to PQ equal to QB. Therefore, I will say that this AF and this CE trisect BD. Then, okay. So let us write these things what we have discussed. Okay, here in proof. So I will make a copy of it, paste here. Okay, so in proof I will say that quadrilateral ABCD, quadrilateral ABCD is a rhombus. Therefore, AB is equals to BC is equals to CD is equals to DA. Okay, is equals to, let us take 2x. E and F, E and F are midpoint of AB and CD. E and F are the midpoint of AB and CD. Therefore, AE is equals to CF. E and F are the midpoints. Therefore, AE is equals to CF is equals to X. Okay, let us take this as equation 1. Now, in quadrilateral AECF, AE is parallel to CF. Reason is this ABCD is a parallelogram, or we can say that opposite sides of rhombus, or better ABCD quadrilateral. Reason is quadrilateral ABCD is rhombus. So AE is parallel to CF. Now AE is parallel to CF. Also AE is equals to CF. Okay, from 1. Therefore we have this quadrilateral AECF is a parallelogram. Now this AECF is a parallelogram. Therefore, we can say that this CE is parallel to AF. This we will consider equation number 2. So CE and AF, they become parallel. Now in triangle, we will take triangle DQC. In triangle DQC, F is the midpoint of DC. F is midpoint of DC. F is the midpoint of DC. Therefore, by F is the midpoint of DC and DP is parallel to I will say that and FP parallel to CQ. You can say this is from CE is parallel to, this is from equation number 2. This is from 2. Okay. So therefore, by converse of midpoint theorem, by converse of midpoint theorem, P is midpoint of DQ. So therefore, DP is equals to PQ. Let us take this as Y. This we will take equation number 3. So we got this as Y, this as Y. Now we will take triangle BAP, a triangle BAP. Now in triangle BAP, we have E is midpoint of AB, and EQ is parallel to AP. EQ is parallel to AP. Therefore, by converse of, this is also from 2, we can say. Therefore, by converse of midpoint theorem, Q is the midpoint of BP. Q is midpoint of BP. Therefore, PQ is equals to QB. Therefore, PQ equal to QB. Okay. This is also equal to Y. From 3 we can say that, because this PQ we have taken Y. PQ is Y. So PQ is Y. So QB is also Y. So from 3 and 4, this is, let us take as equation 4. So from 3 and 4, we have DP equal to PQ, we have DP equal to PQ is equals to QB. Therefore, I will say that this side AF and CE, therefore AF and CE trisect, side BD. Done. Yes. Okay. Simple question. Now let us move to the next question. Show that line segment joining the midpoint of the opposite sides of quadrilateral bisect each other. Okay, so what it is saying, so that the line segment joining the midpoints of opposite sides of quadrilateral bisect each other. So let us draw a quadrilateral of any shape like this. Let us draw A, B, C, D, and let us take midpoints. Take midpoint P, Q, R, S, and join this SQ and join this PR. We have to prove that they bisect each other. They bisect each other. Let us take their intersection point as M. We have to prove that this Sm is equals to Qm, this Pm is equals to Rm. Okay, so given in quadrilateral ABCD, PQRS are midpoints of side AB, BC, CD and DA respectively. Now we have to prove that PR and SQ bisect each other. That is, we have to prove that this PM, that is PM is equals to RM and SM is equals to QM. We have to prove this. PM is equals to RM and SM is equals to QM. Let us do the proof. So here if we draw AC as a diagonal, if we draw this AC as diagonal and join this PQ, this SR, this QR and then this PS, we will be able to prove that this PQ is half of this AC, this SR is half of AC, and then this PQ is parallel to AC and then SR is parallel to AC. So this PQ is parallel to SR and PQ is equals to SR. So one pair of opposite side is equal and parallel. So this PQRS is a parallelogram. Now this SQ and PR, they are the diagonal of parallelogram, and we know that diagonal of parallelogram bisect each other. So we proved, right? Simple. Fine. So proof. We do first a little construction. In construction, we say that draw AC and draw AC. We will write draw AC, comma PQ, QR, RS and SP. Okay. Now in triangle BCA or ABC, in triangle ABC, P is midpoint of AB. P is midpoint of AB and Q is midpoint of BC. Q is midpoint of BC. P is midpoint of AB and Q is the midpoint of BC. Therefore, by midpoint theorem, this PQ is equal to half of AC and PQ is parallel to AC. PQ is half of AC and PQ is parallel to AC. This I will consider equation 1. Similarly, n triangle DAC, DAC, S is midpoint of AD, and R is midpoint of DC, and R is midpoint of DC. So therefore, by midpoint theorem, SR is equal to AC and SR is parallel to AC. This is our equation 2. Now from 1 and 2, this SR is half of AC and this PQ is also half of AC. So SR is equals to PQ. And as they are parallel to AC, they are parallel to each other. So PQ is parallel to SR and PQ is equal to AC. So from 1 and 2, PQ is parallel to SR and PQ is equals to SR. Therefore, quadrilateral PQRS. So therefore, we will say that quadrilateral PQRS is a parallelogram. So PQRS is a parallelogram. Now PQRS is a parallelogram. Therefore, their diagonal bisect each other. PQRS, quadrilateral PQRS is a parallelogram. Now diagonals of parallelogram bisect each other. Therefore, PR and SQ, PR and SQ bisect each other. So PR and SQ, they bisect each other, we have proved. PR and SQ, they bisect each other, right? Now, 7th question. ABC is a triangle, right angle at C. A line through the midpoint M of the hypotenuse AB and parallel to BC intersect AC at D. We have to show that D is the midpoint of AC, MD is perpendicular to AC, CM is equals to MA is equals to 1 by 2 of AP. This is 1 by 2. Okay, this is perpendicular. So ABC is a triangle, right angle at C. So first let us draw a right angle triangle which is right angle at C. Name it as AC and this point as B. ABC is a triangle right angle at C. Now a line through the midpoint of M. A line through the midpoint M of the hypotenuse AB. We have taken the midpoint M. a line through the midpoint M of the hypotenuse AB and parallel to BC. So we have to draw a line through the midpoint M of the hypotenuse AB and parallel to BC, intersect AC at D. So we will draw a parallel side. This is a parallel side to BC and it intersect this AC at point D. We have to show that D is the midpoint of AC. So it is simple, D is the midpoint of AC, right? Because this is midpoint and this is parallel. So D is the midpoint by converse of midpoint theorem. Second, we have to prove that this MD is perpendicular to AC. That means we have to prove that this angle is 90 degree. Okay. Now this MD is parallel to BC. Okay, MD is parallel to BC. So interior angle MDC and BCD, their sum will be equal to 180 degree. Angle C is 90 degree, so angle D will also be 90 degree. So we will prove this part also. Third, we have to prove that this CM, so I have to join this C with M. I have to prove that this CM, I will join, is equals to MA, this CM is equals to MA is equals to half of AB. So M is the midpoint, no? So as M is midpoint, this AM or MB, they are equal and AM is half of AB, that is fine. Now I have to prove that this CM and this AM are equal. So if I check triangle ADM and CDM, this is 90 degree angle, AD is equals to CD, as D is the midpoint and CM is common side. So therefore by side angle side, these two triangles are congruent, therefore corresponding sides are equal. So AM and CM are equal. So we will prove this part also. So understood? Yes. Okay. So right. Solution given. What is given? In triangle ABC, angle C is 90 degree and M is midpoint of AB and MD is parallel to BC. This is given. What we have to prove? Okay. So all these three statements we will write. D is the midpoint of AC, MD is perpendicular to AC, CM is equals to this, and then proof. So before proof, we have done a little construction. So here I will write construction. And construction, we draw CM. Now we will write proof. So first we have to prove D is the midpoint. So I will say that in triangle ACB, M is midpoint, M is midpoint of AB and MD is parallel to BC. Therefore D is midpoint of AC. So therefore D is midpoint of AC. So D is the midpoint of AC. Next, so D we got midpoint of AC. Now we have to prove that they are perpendicular. So MD is parallel to BC. D is the midpoint. So this one part we have proved. Okay. Now MD is parallel to BC. Therefore, first let us copy this diagram. Let us copy here. Okay. MD is parallel to BC. Therefore, angle MDC plus angle BCD is equals to 180 degree. Reason is interior angle. Okay, so their sum is 180 degree. So as their sum is 180 degree, their addition is 180. So angle MDC plus this is 90 degree is equals to 180 degree. So therefore my angle MDC will be equal to 180 degree minus 90 degree is equals to 90 degree. Okay, so angle MDC is 90 degree. Therefore, as MDC is 90 degree, therefore this MD is perpendicular to AC. Therefore, MD perpendicular to AC. MD and AC, they are perpendicular. Now third, we have to prove that AM and CM equal. So for that, this also we can underline, put in bracket. In triangle ADM and triangle CDM, AD is equals to CD. Reason is D is midpoint. D is midpoint of AC. So AD is equals to CD. Then angle ADM is equals to angle CDM, each 90 degree. And we have this side MD is equals to MD, common. So therefore triangle ADM is congruent to triangle CDM. Therefore AM equal to CM. Therefore this AM is equals to CM. So AM and CM, they are equal. Okay, so let us take this as nowhere we have given any equation, so let us take this as equation 1. Also M is midpoint of AB. Therefore AM is equals to MB is equals to half of AB. This is equation 2. So from 1 and 2 we can say that AM equal to CM is equals to MB is equals to half of AB. So this third part also we have proved. CM is equals to MA, CM is equals to AM. Okay, MB we do not have to write. This MB, there is no space for this MB. Okay, we can directly say that this is equals to AM equal to CM is equals to half of AB. Okay, done. So last statement, hence proved. Thank you. Okay, so we have done all the questions of this exercise. Okay, I hope you understand all the questions. Practice, right practice is the key to success. Okay, if you are doing right practice, if you are understanding the concepts and doing the practice, then you will find this subject easy, interesting and challenging. Okay, so geometry is little challenging. So revise your textbooks read your textbooks. I always say that in mathematics also you have to go through each and every statement. Okay, they have explained it beautifully how the things are done, right? Thank you. I will meet you in the next class with a new chapter.